In this lesson, we're going to take a look at how to create splines that fit into other geometry very smoothly. This is, after all, the main point of having a spline, is being able to create geometry that changes radius smoothly from one entity to another. So we've got some sketch entities already open on the screen for us, and this is due to our spline practice part in the Chapter 3 folder. If you'll take a look at your SOLIDWORKS 2013 Advanced Course Working Files for Chapter 3, you've got spline practice.solidpart. Just go ahead and open that up. And this just gives us some existing arcs on the screen, kind of random orientation. It's our goal to play with this a little bit and to see how we can fit splines into this to try to make nice, smooth transitions between the arcs. One thing that beginning users are usually tempted to do is to try to make a spline smooth by creating a lot of points. So if we try to do that, I think back to my days when I started out drawing splines. Maybe I would have done something like this. Maybe adjusted this one a little bit. Try to just by eye get everything very smooth. But you really can't get this that smooth by eye, and you certainly can't get it that smooth by putting a lot of points down. If you're going to use a lot of points in a spline, it's going to have to be points that are mathematically calculated. Let's try to measure how smooth this is, and the only way we really have to do this is using the curvature comb. The curvature comb shows us that in this area, it's just about straight, and then it gets a big lump in it, and then it comes down to almost tangent to a straight line, and over here, it's a little different story. So trying to do this manually hasn't really worked out. It turns out that as you remove points from a spline, the spline actually gets smoother. You see that already by just removing that one point. Spline is smoothed out, so let's remove this point. And you can see with every point I remove, it gets smoother and smoother. So the obvious pinnacle of a spline with very few points is a 2-point spline. Let's create one. Unfortunately, the 2-point spline is a straight line. But we can assign curvature continuity or tangency to the end. Now let me explain a little bit about the difference between tangency and curvature continuity. Tangency just means that the two entities are tangent, but curvature continuity means that they are tangent and the curvature of each item matches at the endpoint. So if I assign curvature continuity, then I look at this, you see SOLIDWORKS is giving a tangent symbol because that's part of curvature continuity. But it also gives this C equal, which means that the curvature of the circle is equal to the curvature of the spline at its endpoint. Let's click on the circle and use the Convert Entities option. This brings that arc into the current sketch as an active entity. So now I can right-click on it and show curvature comb. The curvature comb on the arc is a constant value because an arc has a single radius. Right-click on the spline and show curvature comb. Curvature comb on the spline changes because the radius is constantly changing along the length of the spline. But notice that up here, in this area, the curvature comb height of the spline is equal to the curvature comb height of the circle. This is what we are talking about with curvature continuity, so that as you transition from one curve into another curve, you don't have a sudden jump in the radius. That's what we use to make sure that we have a smooth curve and a smooth transition between curves. Let's do the same down on this end. Add the C2 relation. And you notice that visually, it looks like a very smooth curve. And also, if you click on it, you can see that even though the curvature comb is small, it looks to be smooth. To increase the size of the curvature comb, you can right-click and from the menu, select Modify Curvature Scale. And the density will increase the number of lines that come off, and that's not really what we want. What we want is the size of the comb itself. Say okay. The default pale yellow doesn't show up very well against the white background, but once we've increased the scale, you can see that the curvature comb at the end of the spline matches the curvature comb on the arc. And the same would be shown down here as well. Now, there are a couple of other things that I want to talk about with regard to splines and smoothness. One is that if you need to get something that's even smoother than this, there is a way to do that. Let's start out with an arc, a couple of arcs. Now we want to connect these with a spline. So let's draw in a spline here and put an intermediate point. Let's anchor this and anchor this. Just don't want those arcs to move that much. Okay, now window select and C2, window select and C2. Now this is nice, but if we select all of these items and apply the curvature comb, it shows something that's nice, but maybe we want it even nicer, or maybe we just don't want this break in between the items. So one thing you can do is you can control select all three of these, and then go to the spline dropdown and use the fit spline. The fit spline gives you some options where you can delete the original geometry. You can create a closed spline that'll make a closed loop. It can be constrained or unconstrained. And you can preview various items like the inflection points, the minimum radius, and the curvature comb. Those are very nice. The tolerance can be an important thing here. If you have a very small tolerance, it means that the spline is going to try very, very hard to be exactly the same as the geometry that it's laying over. But if this number is much bigger, let's just key it in to 0.125, that means it will allow the spline to be smoother and to not fit the other geometry quite as well. It's up to you if you want to have a very tight fit or if you want to have a smooth spline. Most people will choose the smooth spline because it just works out so much better. Also, a spline that tries very hard to fit into a line and arc situation is going to have some spikes on it. Let's take a look at a condition like that, where we've got a line, an arc, then a line. We're going to join all these together into a fit spline. And let's just have it delete the original geometry so we get rid of that. We don't need it anymore. So it's just made a spline. And if we look at this and show the curvature comb, you can see that it's got little devil horns on it, and that this area in the middle is kind of constant radius, but that it does have some sort of a spike right on this end. That's not necessarily very attractive geometry. Another thing that you can try sometimes with the fit spline is to use it to actually transition between sketch items that don't touch. So if we try to select both of these lines, make a fit spline, SOLIDWORKS is going to bridge between them automatically. Let's show the curvature comb, and we can see that this is actually smoother than trying to allow it to fit over an arc. Fitting between sketch entities that don't touch can be a useful trick. Now here's one more thing, a situation that you may run into from time to time. Let's say that you've got the need to create a corner with your spline. So you've got to create a straight section and then create a corner and then another straight section. Well, SOLIDWORKS changed the algorithm for creating splines a couple of years back, and so it's always going to try to predict curvature for you, and in cases like this, it's just really disastrous. So what you need to do when SOLIDWORKS creates a big W shape like this, and you're just looking for a corner, is you're going to have to manually rein these things back in. So you have to grab the connectors for this and just shorten them quite a bit and get them pointed in the right direction. Then you can try to make a real corner out of this. Now, if what you need is a straight line and an arc and a straight line, then by all means, create a straight line, an arc, and a straight line. But if you just need a spline with a bend in the middle, that's actually something that's a little trickier. You'll never get this just by sketching it directly. It'll be something that you have to play with and tweak and adjust and go back and look at it and turn on the curvature combs and whatnot, make sure that everything's good. So the curvature comb in this case, very flat in the area where we've got a straight line, and then it peaks around the corner.